Okay, so this chapter is called The Mole, and this is just day one of the chapter. First thing is, make sure that you know the definitions that are up here. I could read them to you right now, and it just sounds like a bunch of science mumbo-jumbo. I will show you how to do it, and then I think I want to go back after I show you how to do it and read it to you, and it will make a lot more sense. Okay, so first thing, though, is to know what we're talking about. We're talking about formula mass or molar mass, which is pretty much the mass of these atoms, how much they weigh. Whether you're on Earth or the moon, the mass would stay the same. And you get the mass from the periodic table. If you look at it, it's the number on the bottom of the periodic table. Okay, so here it says, calculate the formula or molar mass of the following. The first molecule they give us is O2. There's 2 oxygens there. So when you look up the mass of oxygen, what do you get? Look on the periodic table. Anyone? 15.9. Thank you. Okay, 15.9994. Okay. But there's 2 of them, so I put a 2 there. And when you calculate it, you should get a total. And by the way, it would be a good idea to take out your calculator because you will definitely need it for this chapter. Do not forget it on test day. Okay, AMU stands for atomic mass units. That means the mass of just one atom, or in this case, it's a molecule. Okay, now that you can see what we're doing, how we're figuring out the mass of the entire molecule, let me show you this definition that's up here. The formula mass or molar mass is the sum, meaning you add them all up, of the relative atomic masses, meaning the mass from the periodic table of all the atoms in a compound. This mass is equal to 1 mole of that substance, which is why formula mass is also referred to as molar mass. Okay, so like I said, that just sounds very scientific. Get in the habit of knowing this information. I promise it's on the test. Okay? But overall, what we're going to do is add up the mass from the periodic table of every single element in these compounds or molecules. Okay? So let's look at the next one. We have calcium. Cyanide is in a parentheses of 2. Look up calcium. What do you get? Okay, good. And it's 40. Now, by the way, eventually you can round off maybe to 2 decimal spaces after the decimal. But for today, I'm writing out the entire number just so you can see exactly where I get these numbers from. I have 1 calcium, and so that's why I put a 1 there. Okay? How many carbons do I have here if the entire thing is, thank you. We have 2. 2 carbons, it's in parentheses, it says it right here. So we have 2 times the carbon. If you look up carbon, it's 12.01. Then we have nitrogen. Again, there are 2 of those. Nitrogen weighs 14.006. Okay? Now, it's important that you know how to punch it into your calculator. But I think you guys are perfectly capable, so I'll go ahead and give you the answer. This is the easy stuff. I'm not concerned about you guys knowing how to do this. Like, you literally would just add up every single atom that's within the molecule or compound. By the way, eventually I'll get into more details about the difference between a molecule or a compound. The definition of a molecule is any time you have 2 or more atoms. So technically, the oxygen is 2 or more atoms, and this is also 2 or more atoms. Okay? But a compound is if you have different atoms. So the second example is a compound, but the first one is not a compound because it's only made of one type of substance. So the first one is called a molecule, okay? But I'm going to write that on the board eventually. Just wanted to point that out to you. Okay, do you get the hang of it? How many carbons do I have here? 12, 22 hydrogens, 11 oxygens, and so you would simply look up the mass of each one. You would set it up in the same way that we've been doing, okay? I'm going to write it out for you just so you can have it, but I would like to move on to one that's a little bit more complicated that you guys have in your worksheet. I do not have it on my handout right here, but it's a good one to prepare you for the harder ones that you might see. Now, this is pretty basic stuff. The one that gets a little bit tricky, let me find it in here. Okay, in your little examples from the homework, you have the one that's on there and it says aluminum acetate, okay? What I want you to realize is what aluminum acetate actually consists of. So how many aluminums does it have? 1, okay? This is the tricky part. And so what I did was I wrote it on a separate sheet of paper here just to show you if I have in parentheses the 3 there for the acetate, what this is telling me is that I have 3 of those, which is the same as doing this, but we don't want to have to do that every time. That's a lot of work, okay? So if you have something this complicated, how many carbons do I have? And don't forget that there's carbon in 2 different locations here. But there's also a parentheses of 3 around it. So how many carbons do I have? 6, okay? And if you don't believe me, look down here. 1, 2, 3, 4, 5, 6. Hydrogens, there's 3 of them here, but the entire thing is in a parentheses of 3, making it 3, 6, 9, okay? Oxygens, there's 2 within the parentheses, but that's wrapped around with a 3, so 2, 4, 6. Just make sure you have the right number of each one before you start adding, and you will be fine. Okay, so that part, I'm just going to move on because I know that you guys know how to add up. This is the part that gets a little bit more difficult, but even this is not all that bad. You have percent composition, which is the mass of each element in a compound, meaning if you were given something like example number 1, it says, find the percent composition of hydrogen in water, meaning they want to know the mass of just hydrogen in the entire molecule of water. So if this is the formula, and you do need to memorize it for the test, the total mass of just the element divided by the total mass of the compound. So here we go. We're looking for hydrogen. Water is H2O. Now, by the way, this chapter, we don't expect you to know all that stuff from last chapter. So if you never got it, you can still move forward and still be successful. Thank God, right? Okay, so water is H2O. The formula says percent mass of hydrogen is what we're looking for, okay? So now, the total mass of the element. What is the mass of just hydrogen by itself? And realize I have 2 of them here. Okay, so I'm going to put that I have 2 times the 1.01 for hydrogen divided by the total mass of the water. Now, can you tell me what the mass of the water is? Now, here's the thing. If I wrote it down here in parentheses, I found that my students end up punching it in wrong on their calculator. So for now, I'm just going to ask you to do it separately, like on the side somewhere. I have 2, this is the same thing we did up here. I have 2 of the hydrogens, 1.01, plus the 1 oxygen, which is 15.9994, okay? And you would end up with 18.5 Thank you. Okay, so now that we have that for water, we can plug it into the total mass of the compound. Times 100 when you do the math. And I would like you to try it yourself, because anybody could look to see if I did it, but are you able to calculate it on the test yourself? And the answer is 11.18 grams, or actually I'm just going to put percent of hydrogen, okay? Now listen, it doesn't ask you for oxygen, but let's do oxygen because this is what your homework looks like tonight. Yes?
Will you give an answer that's like slightly off? Is that okay?
Yes. If your answer is a little bit off, don't worry about it. I promise the multiple choice responses are not going to be that close to each other. I feel like I need to brighten this a little bit. Okay, let's just do oxygen real fast. Now it's too bright. Good enough. Okay, oxygen, percent mass of oxygen. Okay, so what goes on top? Anyone? Okay, good. The mass of oxygen, and I only have one of them, so I can just put the one value there. Divided by the total mass, which is 18.014, times 100, and you would get 88, about this answer. I do not have my calculator out, so, and I'm going to put oxygen. I don't know why my students are getting confused when I write O by itself. Okay, now this gives you the information you need for homework for tonight, but we do a lab where we actually weigh things out, like as in on a mass, and we get grams. And rather than having atomic mass as our problem, we will actually have a physical sample of water where you weigh it, and you have to figure out how much hydrogen to oxygen percentages or proportions. And what you would realize is that regardless of how much water you have, you would always have the same percentage of hydrogen to oxygen. It's going to be the same ratio every time. So look at this problem. You're given a 5-gram sample of a mystery substance. We don't know what it is, but the entire sample is 5 grams. Analysis shows that 0.559 grams of the sample are made up of hydrogen. Okay, so I know the hydrogen is 0.559 grams. The rest of it is made up of oxygen. Okay, so then it says find the percent composition by mass of both elements. Okay, so let's do hydrogen first since they gave it to us. Percent mass of hydrogen. They tell us it's 0.559 grams of hydrogen. What do I divide it by? 5. Yes, the 5 grams, which is for the entire sample. It's really just a percentage. And I don't know what the sample is at this point, so I'm just going to keep calling it sample. You do the math, and you will discover that your answer is still 11.18% of hydrogen. Okay? How can we figure out the rest of the sample? The remainder of the oxygen. Okay, does anybody have any ideas?
Can you just subtract it?
Absolutely, yes. He's saying subtract the total from what we know, and the remainder would have to be oxygen. That's all that's left in it, those two substances. So you would do 5.00 grams of the sample minus 0.559 grams of the hydrogen, and whatever is remaining would have to be the oxygen. You divide it by what? Again, the 5 grams of the entire sample. And really, at the end of the day, you're just using that same equation over and over again. Times 100, you would do the math. And you know what? Anytime you deal with water in this class and you're asked to find the percent composition for hydrogen and oxygen, it will always be this ratio. Let me scoot this over a little bit. Okay. Okay, so that's it.
Well, like this, can we just subtract 11.18% from 100 and get a percentage?
You absolutely could, yes. Say you wanted the shortcut and you didn't have to show work and you're doing the test. He's saying, could I have just subtracted the 11% from 100 and gotten my 88? Yes. Then you wouldn't have to do all that. Okay?